Hello everybody, hello my students. Today we will start within topic 6, which it talks about the chemical reactions, the rate of chemical reaction, and the factors that affect the chemical reaction. In our syllabus, IGCSE 0620. First of all, you shall differentiate between the physical and chemical changes. You shall identify the physical and chemical changes and describe the difference between them. The main differences between the physical and chemical change. In a physical change, when a substance undergoes the physical change, its composition remains the same despite its molecules being rearranged. For example, changing water from ice to liquid. So the order of particles changed from flat structure or solid structure to liquid structure where they can slide over each other. In a chemical change, when a substance undergoes chemical change, its molecular composition changed entirely. Thus, the chemical change involves the formation of a new substance. In a physical change, it's temporary change, while in a chemical change, it's a permanent change forever. The physical change affects only physical properties like shape, size, etc., and color, and so on. Chemical change, both physical and chemical properties are changed. So for the new chemical substance, you have maybe new color, a new taste, a new physical properties, and so on. Some examples about the physical change: freezing, melting, boiling, sublimation, and so on. Few examples about the chemical change like digestion, combustion, burning process. The physical change not involve the production of energy, while in the chemical change there is an exothermic and endothermic reaction, so they can produce energy or release the energy or takes an energy. So in the chemical change where we have a chemical energy change. In a physical change, no new substance is formed, while in a chemical change, always accompanied by one or more new substance that produced. The physical change is reversible process. For example, if you melt water, you can freeze it again and you can reverse it. While the chemical change, like when you burn fuel, you can't return back again. So you can't reverse the chemical reaction. Not all reactions are reversible processes. Okay, as an example for an assessment for your knowledge about the physical and chemical change, here we have two questions. The first one, the sour milk smell badly because the bacteria have formed a new substance in the milk. Is that a physical or chemical change? He said that there is a new chemical substance which is formed, so this means that there is a chemical change. In the second question, sand flowing in an hourglass is an example of a chemical change or physical change. There is no change on the identity of the sand. So it's what? It's a physical change. So everything stays the same and there is no production of a new chemical substance. Here you have a question. Try to do this question to make an assessment for yourself. The second part of our lecture is the rate of the chemical reaction. We shall define the rate at the beginning, and we shall use the collisions theory and they ask a lot about the collisions theory and where are the number of particles per unit volume is required. You shall talk about the frequency of collisions between particles and the kinetic energy between the particles, and how much the activation energy is very important to explain the rate of the chemical reaction. First of all, what's the rate? If I ask you this question, the rate is measurement of the change that takes place per unit time. Okay? So the rate is the measure of the change that happens in a single unit of time. The rate of the chemical reaction, in the chemical reactions, we have reactants and products. So what we measure the consumption of reactants per unit time or the production of products per unit time. Imagine that we have this chemical reaction which is happened between zinc and sulfuric acid. The products are zinc sulfate and hydrogen. Here, this is the balanced chemical equation to show up that the hydrogen gas was bubbles off in this chemical reaction. Here we have zinc, which is in which the hydrogen gas is produced. We can measure the rate by follow up these amounts. First one, the amount of zinc used per unit time, or the amount of sulfuric acid used per unit time. The amount means moles, grams, mass, volume, and so on, or the amount of zinc sulfate produced per unit time, or the volume of gas, or the amount of hydrogen gas that produced per unit time. By these methods, we can measure the rate of this chemical reaction. What about the collisions theory? First part, or the first important thing in the collisions theory, the particles must collide with each other to react. The question is, if all collisions are successful, if all collisions leads to the chemical reaction, no, the collisions must have enough energy to be successful. In other words, they have enough energy to break the bonds and allow reaction to occur. The rate of the reaction depends on how many successful collisions there are in a given unit of time. Here we have two examples. In the first example, there is a good orientation or favorable geometry between the particles. We have this kind of molecules and this kind of molecules. When they have good orientation, favorable geometry, there are products. But in other side, if we have a poor geometry, when they met each other in a different angle, there is no product, so the molecules stays the same and there is no chemical reaction. So again, for successful collisions, we need two things. The first one, the specific amount of energy, and we shall know that this amount of energy equals the activation energy or higher. So we will use the factors of the rate by increasing or decreasing the energy of the particles or the amount of particles. Here this diagram shows that not all particles, they have enough energy to react. Only the shaded area, which represents the particles of successful collisions. The particles which they have the amount of activation energy or more, they react with each other. That's what is meant by the effective collagens. How we can change the rate of the chemical reaction? The rate of the chemical reaction can be changed by changing the concentration of the reactants or by changing the pressure of the gases. It seems like the change in the concentration of the reactants, or you will decrease or increase the surface area of the particles, and also we can change the rate by another factor, which is the temperature. And from the most important factors which they increase the rate of chemical reaction are the catalysts or enzymes in the biological reactions. So the factors or the main factors in affect the rate of chemical reaction are concentration, temperature, surface area, using catalyst, pressure for gases. Sometimes light is considered as a factor which increase or decrease the chemical reaction. For the photochemical reaction or photosynthesis, the light is important factor. Why the rate increases with the concentration? Again, imagine that we have this reaction between magnesium and hydrochloric acid to produce magnesium chloride and hydrogen gas. As you can see there, we have dilute amount of acid. We have this amount of acid. There are not so many acid particles, so there is a less chance of an acid particles hitting the magnesium particles. But if there is a lot of acid particles and the acid is more concentrated, the acid particles have greater or more chance to hit the magnesium, and there is more chance for successful collagens. Okay, so for the concentration factor, you shall say or mention the following terms: increasing the concentration, increase the number of colliding particles, so they collide more successfully because the number of particles was increased. Here you will see or follow up, if we draw the results and we measure the volume of the gas, of the hydrogen gas that produced per unit time, you will apply the idea in a different way. I mean the idea of the concentration. At the beginning of the reaction, I mean this part of the graph, you will see a large quantity of the reactants, and the concentration of the reactants is very high, so the number of collagens between particles is greater than after or than within going of the reaction. Because if you try to calculate the tangent line, the slope of the tangent line, which represents the rate, you will find it's greater, and the curve at the beginning is steeper. Why? Because at the beginning we have a large amount of particles and we have a high concentration of particles. That's why at the beginning of the reaction the rate is faster, while the slope of the tangent line there, or the gradient, becomes lower, less steep, or it's lower steepness because the particles was consumed from the reaction and there are lower number of collagens between the particles while the reaction going further. Now, so we can apply the concentration factor on the concentration of the reagents themselves, or changing the concentration of reactants, or you can use it to describe the change in the rate by changing the concentration of the reactants. The reaction between gases, the most common factor which affects the gases is the pressure, which looks like the concentration. If you increase the pressure for gases, like squeezing this container, then there are more collisions between particles, and if we squeeze them, this increases the high probability, or there is a higher probability or higher chance for successful collisions to take place. So again, for pressure, so if the pressure increased, the rate of a gaseous reaction increase, because there is a greater chance for successful collisions to take place. What about the surface area? You know, the surface area is a factor that is affected by the particle's size. So the powdered particles, they react faster compared to the lumps or large stones. For example, here, if we use the magnesium atom, the rate or increase, if we increase the temperature there, I mentioned the surface area is there, okay. Why the rate increase with the surface area? Here we use the magnesium ribbon. You know, if you increase the surface area by decreasing the particle size you made magnesium powder, there is a higher chance for successful collisions, and this will increase the rate. Now let us talk about what? The temperature. Okay. If we increase the temperature, we are talking about the same concentration, the same amount of particles, but we elevate the temperature of the reaction. So this increases the kinetic energy of the particles. They move faster. Focus very well there. You shall mention, when you explain the temperature change, that more number of particles have enough energy to react, or more number of particles have the amount of activation energy or higher to react with each other. So that's why there is a higher rate of reaction, and the chance of successful collisions increase. Now, to explain this on a curve, the blue one is the original one, where the reaction, for example, takes place at 30 degrees, 40 degrees. If you increase the temperature of the reaction goes faster, and it is at higher temperature. And you can see that this one in the red color is the steeper the curve, with the higher gradient or the slope of the tangent. But make sure when you draw, you stopped at the same volume and you start at the same point. These are two important things, because we are dealing with the same amount of substances. Okay? We mentioned that, we explained the surface area. Okay, what's the role of the catalyst is? Again, the catalyst is defined as a substance that increases or speeds up the chemical reaction without being changed, or remains chemically unchanged. Like, for example, if you use powdered iron in a chemical reaction, and this amount is 2 grams at the end of the reaction, you can filter it, and you will see that what is left is 2 grams of iron. This is a question that comes in the past papers for the alternative to practical test. He's asking you to plan an experiment to find to prove that the chemical reaction is a catalyst. You can take this substance, then take a specific mass, then you can filter it, reweigh again. If it is the same mass, this means that it is a catalyst because it is chemically unchanged by itself. The catalyst plays a role on the activation energy. It will provide an alternative pathway or route for the chemical reaction by decreasing or lowering its activation energy. You can see in the diagram the purple line, the purple curve represent the uncatalyzed one. So this is no catalyst used. And you will see the activation energy is greater. But for the green one, which is the catalyzed pathway or the catalyzed reaction route, the activation energy was decreased. So that's the role of the catalyst. So if he's asking you what's the role of the catalyst, you shall say that the catalyst speeds up the chemical reaction and it is not chemically changeable, and it provides an alternative route for the chemical reaction by lowering the activation energy or with a lower activation energy. And as an example about where the catalyst is used, here we are talking about the decomposition of hydrogen peroxide, okay, where it is decomposed to water and oxygen. So this will increase by, without the presence of the catalyst, without iron. And you know why I select iron? Because the transition metals are used as a catalyst. You can use manganese oxide, iron oxide, iron, any transition metal or transition metal compound will catalyze this. And for using the manganese 4 oxide here, which is a catalyst there, the glowing splints was relight because oxygen was produced, and we know that the test for oxygen gas. So this indicates that in the presence of the catalyst, like one of the transition metal components, like manganese 4 oxide or any other transition metal compound, the hydrogen peroxide was decomposed to water and oxygen equally. Now, as an example about the catalysts, there is a biological catalyst, which they are the enzymes. So there is a question in the past papers, what are enzymes? Briefly, they are biological catalysts. Why they are biological? Because they catalyze or speeds up biological system reactions. Enzymes are proteins made by cells who act as a biological catalyst. They are working at specific conditions. If the temperature gets too high, the enzymes is destroyed or denatured. And you know that from the biology. You study that in biology. An enzyme also works at specific pH range or the specific degree of acidity and can denature by adding an acid or alkali or base to it. The theory of the catalyst working is known as the key and the lock. Here, the enzymes molecules, they are correlated with the reactant molecules, and if the catalyst comes and reacts with the reactant molecules, leads to breaking down, forming the products. But what's the important thing is to see that the catalyst stays the same. It is unchanged. You see, the red color shape stays the same. This proves that the catalyst was unchangeable in the chemical reaction. That's why the catalysts are used. They form like a surface where the reactant molecules are, listen carefully, adsorbed, not absorbed. They are adsorbed, so they are coming on the surface of the catalyst. Then the bonds are broken, and then there is a desorption process, and the reaction takes place to break down the molecule. The role of the catalyst is very important in going or for the reaction to be fastened. That's everything. For the factors affects the rate of the chemical reaction. We can discuss more and more things like how we can measure the rate of the chemical reaction. We will discuss some past papers questions about the rate of the chemical reaction. You know, most of the past papers questions for this topic comes in the alternative to practical test, where drawing skills are very important, and the explanation is very important, and the analysis is very important, leading to the full marks in this question. There are a lot of marks on the rate question, so make sure that you can follow up our videos for more details about the chemical reaction. Thank you for good listening. Thank you very much. That's me, Bishr Samhan, chemistry teacher for the IGCSE tests and all other international programs. Follow me for more videos, for more details about our topics in our syllabus.